All right, today we're going to continue our work on piecewise defined functions. Today we're going to get into more defined areas of the graph, I guess, that have a slope and a y-intercept, and look at how that works. We're also going to take a look at what continuous means in terms of graphing a function. All right, so let's jump into it here. So now you're going to see that we have this function, which we'll just call f of x, even though I have an h here. So f of x is equal to, and there's two different rules. All right, 2x minus 1 if x is less than 1, and opposite of x plus 2 if x is greater than or equal to 1. So our x-axis is only being broken into two different pieces. One graph is going to go from, for all values less than -1, and then the second graph is going to pick up at 1 and be for all values greater than 1 on the x-axis. All right, so we do this the same way we did the last ones. Okay, we're going to graph it in its two pieces. All right, so the first piece of the graph is for all values less than 1. Okay, so when x is less than 1, they're saying use the rule f of x equals 2x minus 1. All right, so in other words, from -infinity to 1, so from -infinity all the way up to 1, we're going to make the graph y equals 2x minus 1. Now, you guys know how to graph this equation because it's in slope-intercept form, right? This line has a slope of 2 and a y-intercept of -1. I'm going to use that information to sketch the graph, okay? And then we're only going to want we're only going to want the part of the graph from -infinity up to 1. All right, so let's go ahead and make the graph. So b at -1 means we're crossing the y-axis here at -1. I got a slope of 2, so that's a rise of 2 and a run of 1. That takes me to another point on my line. And then I just kind of sketch in my line here so I can see it. Now, the key to this is we're only interested in the part of the line that goes from -infinity up to +1. So I only want this part of the line from 1 to the left. Okay. So, and now I'm not going to include 1 either. So it's going to look like this. Okay. Open circle at 1. And then we're going to go all the way to the left here. Okay. So this graph is defined from -infinity to 1. And there's what that line looked like. Okay. Now we're going to graph the other piece. Okay. So the other piece of the graph is for values of 1 to +infinity. So how is the graph going to look from 1 to +infinity? Well, they say for values greater than or equal to 1, use the rule. Okay, it should be f, sorry. F of x equals -x plus 2. I got it right out of here, right? F of x equals -x plus 2. So basically that means from 1 to infinity, we make the graph y equals -x plus 2. Now you know how to graph that, okay? Slope is -1, y-intercept is 2. Okay, so I'm going to graph this line, and then we're only going to want the part of it that's from 1 to +infinity. Okay, so cross the y-axis at 2. Slope is negative, and if you want to rise and a run, it's 1 over 1, right? So I'll go up 1 to the left 1. That gives me a negative slope, and there's another point right there. Okay, now put our line through here. That's the line that's created by this graph, but we only want the part of the line from 1 to +infinity. So from here to there. Now notice I'm going to include 1 on this graph. Okay, so the rule allows me to fill this in, and it's filled in for the second piece of my graph. All right, now the next question is this continuous? So what does it mean to be continuous? That means there's no gaps or holes in the graph as you look at it across here. So from -infinity up to 1, I have this rule. At 1, I have an answer, and then I got all of the answers going to the right. So there are no gaps, there are no holes in this graph as you move left to right. There's an answer for every x value. So yes, it's considered a continuous graph. Okay. All right, let's try another one of these. So here's my rule. Again, that should say f, sorry. So for values less than -2 on the x-axis, so starting at -2 and going this way, I'm going to use the rule f of x equals x minus 2. For values greater than or equal to -2, so for values greater than or equal to -2 this way, I'm going to make the graph f of x equals 3x plus 2. And then we're putting it all together on one graph. So let's go ahead and do that. So we're going to graph the piece of the graph for values less than -2. All right, well, it says up here, when x is less than -2, then f of x equals x minus 2. So use this rule. So what this means is from -infinity to -2, make the graph y equals x minus 2. So from -infinity up to -2, make the graph y equals x minus 2. So what do we know about the graph here? Well, we know this has a slope of 1 and a y-intercept at -2. So make the graph. Cross the y-axis at -2. You got a slope of 1, that's up 1 over 1. There's another point on my graph. 2 points, make a line. There's my line. Now, the only part of this line that I want is the part of the line from that are less than -2. So I'm only going to pick the line up right here. Okay, so when x is -2 right here to the left, because that's towards -infinity, right? So this is the only part I want of this line here, that way. Okay, because when we're greater than -2, I'm going to define it with this rule. So the second piece of this is for all values greater than or equal to -2. Okay, so when x is greater than or equal to -2, now we're going to follow this rule: f of x equals 3x plus 2. Okay, right here. So what do we know about the, well, let me just say this. So from -2, all the way out to infinity, we're going to make the graph y equals 3x plus 2. All right. So what do we know about this graph? Well, we know it's got a slope of 3 and a y-intercept at 2. That's going to let me make it. So we'll go up here and y-intercept is at 2. The slope is 3. So that's a rise of 3 and a run of 1. Right. That takes me to another point, and then connect those points. So here's this graph, right? Right here. Now, what part of that graph do I want? Well, I want the part of the graph that starts at -2 and goes to infinity. So I want to start here and take this piece of my graph. All right. That's a piecewise defined function. There's one rule from -infinity to -2, and a second rule from -2 to positive infinity. All right. Now, is it continuous? Are there any holes or gaps in it? No. Every value of x is covered, right? I can input any value of x I want and get an answer that's continuous. Okay. All right. So there's your work on piecewise defined functions, day 2. They're going to be a little bit more linear. The first day, we dealt with horizontal lines. Now we're going to deal with slopes and intercepts and piece it together. Okay. Go back and look at any of the examples you need. All the information is there. Okay. And I guess I'll let you have at it.